Greetings, fellow SAT aspirants. Welcome to this next video, which we have on inequations. We have talked about how to graph standalone inequation graphically. Uh, but it's important that we know how to solve a pair of inequations by graphing it, right? So we have a pair of inequations, and we want to know that what is the common region, which is for that, because we know very well now that an equation represents a region, right? So when we have a pair of inequations, it's important for us to know that what is the common region for it, and which is actually the solution of it as well. So let's talk about that. It's procedure remains the same, as simple as we need to graph both the inequalities and find the region which is actually common to both. So let me just draw the coordinate plane over here. Uh, so we know that in order to graph the region, we first graph the equation and then we just find the test point and then we graph and we initiate the region. So x equal to -3 is the first line. So x equal to -3 is definitely a vertical line, which is going to look something like this. And I'm making a dashed lines already because I know that the equality sign is not included anywhere, so that line will be dashed. So this is x equal to -3. And now we talk about y equal to 4. So y equal to 4 will be a horizontal line, which is like this. So if you're wondering how is that a horizontal line, remember we have talked about this in graphing the equation. So you might want to recheck that video in case this is giving you a hard time. So y is equal to 4. And now we want to know the region. So x is greater than -4. I think the origin is a good test point for both this. So 0 comma 0, if we place in the first inequation, then this becomes 0 is greater than -3. Is 0 greater than -3? Yes, 0 is greater than a negative number, and hence the shaded region will be towards the origin, which is over on the right. Likewise, if we place 0 comma 0 in the second one, so 0 is less than 4. Is 0 less than 4? Yes. So the inequation will definitely point towards the origin. So the common region will definitely be this. So all the region which is over on the right of x equal to 9 -3 and which is on the down of y equal to 4. So the common region will be this one. Right, and remember that the lines will be dashed over here. So this shaded region is the solution of the pair of inequation which are indicated over here. Talk about the next one. So once again, we have to first graph the equations, and then we have to talk about the inequations of the regions. So x plus 4y is equal to 10. Let's find out the 2 points first. So if x is equal to 0, then 4y is equal to 10, which means that y is 10 over 4. 10 over 4 is nothing but 5 over 2, and 5 over 2 is nothing but 2.5. So one of the point is 0 comma 2.5. And if y is equal to 0, then x will be equal to 10 over here, which means that 10 comma 0 is another point. Right. Let's talk about the same kind of activity for the other equation. So if x is equal to 0, then minus 2y is equal to 12, which means that y is 12 over negative 2, which is negative 6. So this is 0 comma negative 6 point. And if y is equal to 0, then 3x is equal to 12, which means that x is equal to 4, which means that the point is 4 comma 0. And now we can easily graph this equations. So I'll just make the coordinate plane over here. These are the arrows. Will the lines be solid or dashed? I think both will be solid because it's greater than equal to sign is included in both. So for the first one, I think I'm gonna need 0 comma 2.5 as one of the point, which is somewhere over here, and 10 comma 0, which is somewhere over here. So 10 comma 0, and the line is going to look something like this. When we talked about 0 comma negative 6, so 0 comma negative 6 is somewhere over here. And then we have 4 comma 0, so 4 comma 0 will have somewhere over here. So we'll uh, have the equation, we have the line like this. Now we need to talk about the region. So I think the origin test point works fine with both. So if we use the origin in the first inequation, then we'll get 0 is greater than equal to 10. And in the second one, we'll get 0 is less than equal to 12. Is 0 greater than 10? Not really. So for the first one, the region will be away from the origin. So that will be like this. Is 0 less than 12? Yes, indeed. So its region will be towards the origin. So it will be over here. So what will be the common region? So let's be careful about that. I think the common region will be all the region which is over here, then everything which is over here as well. So I think this region is the one which is common, right? So let me just graph it. Let me in fact shade it over here. So this will be the required region, which is common for both of them. And hence this is the required solution for the pair of inequations. Let's talk about the next one. So once again, we'll have the two equations over here. So let's see with x minus 5y is equal to 10. So we have x as 0, which makes minus 5y is equal to 10, which makes it y is equal to minus 2. And hence 0 comma negative 2 is a point. When we make y as 0, then x will just be 10, pretty straightforward. So 10 comma 0 is a point. Likewise, for 2x plus 3y is equal to minus 2, we have x as 0, which makes 3y as negative 2, which makes y as negative 2 over 3. So if you want to approximate, this is somewhere around negative 0.67. And if y is 0, then 2x is negative 2, which means that x is negative 1. So we have negative 1 comma 0. Let's try to graph it, and I think the first line will be the solid because that's greater than equal to, and the other line will be dashed because that's just greater than. So let's just graph it over here. So we have this as the inequation. So over here, we will be having the points as 0 comma negative 2, which is somewhere over here, and 10 comma 0 will be somewhere over here. And if you want to graph it, this will be a solid line. So we'll just graph the solid line over here. All right, this is the solid. I mean, it doesn't really look. I'll just try to redraw it. Okay. All right, so this is one of the line, and the other line is going to be the dashed one. So that's 0 comma negative 0.67 because this is 0 comma negative 0.67. So this will lie somewhere over here, and the other point is negative 1 comma 0, which will lie somewhere over here. The line will be dashed, so I will just draw a dashed line over here. And if we are interested in knowing the region, then of course the origin will come really handy. So if you put the origin, then 0 is greater than equal to 10 is the first one, and 0 is greater than minus 2 in the second one. Is 0 greater than 10? Not really, and hence the region will be away from the origin, and hence this will be the region. For the dashed one, is 0 greater than negative 2? Yes, so the region will be towards the origin, which is like this. And I think if you want to shade the common region, that's gonna be like that's gonna be this one, right? So everything which is in this area, that will be the what do you call it as? That will be the common region, and hence this shaded region is a required solution of the pair of inequality. Let's talk about the last one. So In this case, of course, the origin is not going to work as the test point. So, but let's try to graph y is equal to x and y is equal to minus x. So pretty straightforward lines passing through the origin. If x is 1, then y is 1. I don't even need to put the origin. That's pretty much evident. And if x is minus 1, y is minus 1. So these are the 2 points. Here, if x is 1, y is minus 1. And if x is minus 1, then y is 1. Of course, the sign is going to flip. So this is very easy to graph. Let me just draw the coordinate plane. 1 comma 1 is going to lie somewhere over here, and negative 1 comma negative 1 is going to lie somewhere over here, and definitely the lines are going to be dashed because that's greater than, not greater than, equal to. So this is how the first line is going to look like, and the other line will be this is 1, sorry, negative 1 comma 1, and this will be 1 comma negative 1. So if you want to draw a line, this will be like this. And if we put any point, let's say for y equal to x, right, for y greater than x, which is this line, I want to put negative 1 comma 1 as the test point because it is over on the other side, right? So if I put negative 1 comma 1, it's going to look like 1 is greater than negative 1. Is 1 greater than negative 1? Yes, of course. So this region will be towards this point. And for this line, I'm going to put this as the 1 comma 1 as the test point. So if I put 1 comma 1, then I get 1 is greater than minus 1. Is 1 greater than minus 1? Yes, of course. So it will also be towards this region. So the final answer is going to be uh, this particular region. Everything which is over here is the final answer. So I hope these drill questions makes you understand the fundamentals about the pair of linear inequalities, how to graph them over a single coordinate plane, and how to find the region common to it, and how to, of course, use the test points. So stay tuned for the next video, and thanks for watching this one. Bye bye.